want to use the beat plan, but you can't paint where the blocks were last time. So you move the block so you can paint under it. So you use a different block. But in any case, you set up the block, okay? And it's a transit job. It's a naval architect job. It's a civil engineer job. Everybody comes down. Everybody's in agreement. The blocks are right. Look at the drawing. So then you flood the dock. Okay, you make it equalize to the Delaware River on the other side. Okay? And so then this caisson actually has ballast tanks in it. So it's got water in the ballast tanks. You pump the water out, and then this thing actually pumps out like a cork. Okay, but you only do this when you're ready. You pump the cork out. You got the tugboat to the next ship. You put the ship in. Okay, put the cork back in. Okay, seat the cork. Okay, and actually start pumping the water out. Okay, pump it down, and there's line handlers holding the ship, from both sides. And this is a float. This goes up, and again, we set this all up, but this is the same as the bow up here. So when the water's here, this thing is floating up there, and you want the bow, right above the float. Okay. So anyway, you get it all above the block. You keep pumping the water down, and you get to about 1 foot off the blocks. And then you stop, you send the diver down. There's a yellow rope that goes along the keel blocks you see. The diver goes down and checks to make sure he didn't knock into the blocks. Okay. Anyway, he comes up, says everything's good. You pump it down, you settle on the blocks, and then you pump down until you got about 1 foot of water in here. And then you have to stop again. You have to catch all the fish. It's like an EPA requirement. Catch all the fish, put them back in the river. Okay. The 3 ideals, it doesn't matter what they are, they want them all. Okay, there's fines if you don't catch all the fish. Anyway, catch all the fish, then you clean up all the bugs. Okay, and then you can go to work. Okay? Any questions on the docking process? I get it? There's a rudder back here. The rudder's actually offset, so we can pull the shafts through the strut bearing without dropping thrust. Well, we make a lot of different voltages on here. We have a lot of different skips where we can make different voltages. So we make the voltage that you get. We make 110 to 24. Yeah. And we have some small, really low voltages. Joe, how low's the voltage on the hot voltage? The hot voltage is really low. Hot voltage. So they can make whatever kind of voltage they need. And things start sequencing. Fuel valves are open. ignition should happen, RPM should start going up, temperature should start going up. If any of them don't happen, it's going to shut itself down. But in any case, you push the start button, engine comes up online. At that point, then you can transfer control up to the bridge. The bridge can just go faster, slower. They can't turn them off. Okay, so it's just faster or slower. So anyway, that's all about propulsion. The two LM2500s, they're not making electricity. You know, we've been through the engine room. We didn't talk about electricity. They're just making the reduction gear turn to make that propeller turn that we saw outside. Over here, though, there are 4 diesels on board the ship, each 1,000 kilowatts. They're Detroit diesels. We'll see them in the next space. But you can run 1, 2, 3, or 4, depending on what load you mean. These have nothing to do with propulsion. Okay, these are just making electricity. Now, so you fast forward to DDG 1000. They've got 2 big gas turbines, 2 little gas turbines. We're making electricity for the bus. So we can do whatever we want with the electricity. We can turn the propellers, or we could send it to laser weapons, you know, or whatever we want to do, you know, kind of thing. So that's why we're going with the DDG 1000, making electricity for the bus. So, and over here is an auxiliary control console to run air conditioning plants and stuff like that. So
you can do like split and parallel plant right from here.
Sure, absolutely, on the diesel, sure. You can. Yeah.
Each of those black handles are your tiebreakers.
Yep.
Okay.
Yep.
Wow. It's like Star Wars.
Yeah. So, and if you guys notice that all the drawings on there, even on here on this panel, reflect the actual engine layout, so you can see which engine control what. Try and make it as cell-proof as possible.
Right.
Wow.
Yeah. So there'd be basically 2 guys on watch in here. There'd be an engineering officer of the watch and one of the console operators. And they'd also have a rover that would go around in the spaces and do what they would tell them. They'd say, hey, go check out this flooding alarm. Then come back up and then go open this valve and go do this.
As long as the generators are running, there's someone here
Yes.
in the console.
Even if they're in port on shore power, there'd be somebody here. Yeah, this is
Really?
like an always manned space. Yeah.
Where would the shore power indication be in here to show that?
God, I'm sure if we read these buttons, we'll figure it out. I don't know that answer. Joe Marshall would know that answer.
So when you're coming in from one of the switchboards, you probably have an indicator light on one of the switchboards.
Oh, God. You have totally stumped me, but we could ask Mr. Jones.
Oh, you got a light on right there.
Yeah, that's your ground status test.
Yeah.
So
Okay.
that's how you test for ground. So
Okay.
you switch to an A-phase ground, you hit test, and the light goes out, you got a problem.
Oh, wow.
So.
Okay.
All right. Okay. I promised this group after steering. We're going. Come on. Let's push that thing right there.
Where you got it?
Shore power current, but not voltage.
Oh, okay.
Yeah, it's still current.
But that's all you need. Because once
Well,
you're
you
once you're
gotta have voltage
connected,
so you can synchronize.
well, once you're connected, you get one of these lights on. I'm sure.
That's it.
Generator on, shore power.
Everybody's
Mixed
There you go. It's right there.
Newer sailors don't know what that is. You scare them.
Yeah.
A lot of amperage.
It would come out, and you stop it, flip it out, and that way it would be real noisy. But eventually you get a lot of weight out there, you know, it gets harder and harder to stop it. Then there's, you know, it's all color coded. So like if the white shots are out, that's not too bad. The yellow shots start coming out, you start getting nervous. The red shots start coming out, it's time to run because they probably aren't going to stop it. And then when this chain comes out, it's just going to be whipping around. So anyway, but anyway, they had one anchor. Okay, I've told you about everything I know. You guys got any